Hey y'all, this week at Jam, we just hosted an AI Builder Night last night at Cloudflare in SF, and we thought that the speakers were so interesting that we wanted to share them with you this week on the podcast.
So last night, it's a Tuesday night in November, and we've got this full room, every chair taken, people standing in the back, of engineers listening to each other teach their learnings about how they're implementing AI and building it into products. And how cool is that? When you live in San Francisco, there are a lot of these events and whatever. But when you're there, there's something really profound, to me at least. It sort of feels like, imagine if it was the 90s and we were getting together on a Tuesday night to discuss how to build for the web. It just, I feel like this is the type of thing we'll tell our grandkids about. I don't know. I just, even before, whatever. I think it's cool.
Yeah, no, for sure. Totally good idea to sort of talk a little bit more about that. And I think so too. And it's something really special with Jam events, because I don't live in SF, right? And I don't get to go that often. So when I do go and I see it actually happening, it's it's really the people. It's a vibe, and it's hard to explain, but it's a really good one. And it's nothing that we do. It's just the people that show up. So are we ready? Should we jump in? Do you remember?
Yeah. Let's do it. Without further ado.
My name is Beyang. I'm the CTO and co-founder of a company called Sourcegraph. We build developer tools for developers working in large, messy code bases, code search, and code AI. And today I'm going to talk about building blocks for making AI work in large, messy code bases. So roughly speaking, there's kind of two camps of people in the world. There's people the people on the left are AI is here, AGI is upon us. I don't even write code anymore. I just talk into my iPhone and it writes the code for me. I don't need to hire any developers. My job is done. All our jobs are gone, and we should just embrace the AGI. And then there's other people who are well, I'm a professional dev. I work in a large code base. I'm using this stuff, and it's nifty and cool, but it's more of a toy. It often makes mistakes and messes up. So I guess by show of hands, who resonates more with the guy on the left?
It's okay, take a sample of people who show up on a Tuesday night to talk about AI. Which one do you think they resonate with? And it's AI is here and it's changed everything already, and you better get on board or else. But even but I'm it is so cool to host with Beyang, because back when I was in my first job, PM at Cloudflare, I used to go to this DNS meetup that was in the same building as the Sourcegraph office. I used to walk by their logo one Tuesday every month, and have just sort of been a fan of theirs forever. And I love how they've staked a claim for we are the messy code bases company, and our AI assistant is different than all the other AI assistants because we're for the big messy code bases. One of the people I talked to last night at the event told me that he was using Sourcegraph back in 2019 when they were a very much younger company, back at Uber, one of their earliest big customers, which is really, really cool.
Okay, so I think the $100 trillion question, whatever the market cap of code AI tools is, which one of these people is right? And so a while ago we had this realization, what if they're both right? Well, how could they both be right? Well, I think it might be, what does your universe of code look like? If you're working on new applications or small side projects or small code bases, AI is working really well for that sort of thing. Greenfield codes, building simple apps from scratch. That works really well because the LLMs have been trained on a lot of data that looks like that. Meanwhile, if you're working in a large legacy code base, you might have a very different experience. We hear a lot of people saying, oh, this tool doesn't work so well for me because it doesn't understand the patterns of my code. Maybe I have a special internal language that it's not aware of. And so this is kind of the two worlds that we're exposed to. And so if you're living in the code on the right here, in a large, messy legacy code base, and frankly speaking, I think 99.99% of the code in the world that has actual users and drives actual revenue is going to be messy and legacy to a certain extent, because things get messy as users file bug reports and feature requests. And for that, what we found are not just the LM matters, but prompts and context matter a lot. because you're essentially in what's known as an out-of-distribution situation. So the data that you're working with, this legacy private code that's in your work code base, is out of the distribution of the training set of these LLMs, because the LLMs were all trained on large open source data corpuses, your Stack Overflows, open source on GitHub. And if the code that you're working on was not represented in the training set, then it's out of the distribution, and so you're kind of like, it will try to pattern match the best it can, but it'll make a lot of stuff up, and it generally won't work as well.
This is so true. So like one of the things that we ran into was for a while there were all these like demos on Twitter of like LLMs solving bugs on their own, and like those demos are so compelling and really, really exciting. And obviously, like as an engineering team, we were like, let's chase this at full force, and we did. And the thing that we ran into quite quickly was they are like, these LLMs are so good at solving a bug. If you are in the Create React app or like whatever demo app there is like 10,000 of these on GitHub and it's been trained perfectly. But as soon as you're actually building something real, it is so bad at fixing the bugs that it's actually like insulting and would degrade trust with our engineers unless we were doing like custom model training on each customer's individual code base, just like state of AI. So anyway, like what he's saying just rings so true.
Okay, let's see the next one. Tejas, I think.
So a little bit of Jam history.
Yeah.
Way back in the early days of Jam, we contracted Tejas and he built like the first screenshot mode. So I haven't seen Tejas. I've actually never met him in person, but haven't talked to him in like 3.5 years. And he like shows up yesterday. Literally, like the Sourcegraph team invited him to speak yesterday morning, like the morning of the event. So I had no idea. I just showed up and there he was. And it was like so cool and like so happy to see him.
Hi everyone, I'm Tejas. This is going to be a speed run. So over the course of my career, I've had the privilege of working at all these nice places in various capacities. And today, I proudly work at DataStax. I deleted some slides accidentally, but here, this is where I work. My team's all here. What's up, DataStax team? Pound. Great.
DataStax team in the front row is like the joy of software. I love startups.
Anyway, and I get to talk to you about AI. I want to start by talking about LLMs, because LLMs are huge. It's in the name, large language models. And these have evolved a lot to today where there's hundreds of billions of parameters. So many parameters for an algorithm to run through to give you an inference. You know what that means? That means you need a tremendous amount of compute for results that are kind of not that good. Right? Because like, for example, with Google's AI overview feature, there was a lot of misinformation in the beginning, right? How many cigarettes should a pregnant woman smoke? 3 to 5 per day, according to Google. Wrong. But that's because there was nonsense in the training data and there were so many parameters. And so if we consider where AI must go to be useful, we must consider that LLMs may be better, this is wrong, what maybe LLMs need to change into, that's better, thank you, is smaller language models with fewer parameters and fewer places things can go wrong that require lesser compute. Where do we see this? I think the most visible place we see this is Apple Intelligence, right? On-device model, because it's so small, that does RAG with a semantic cache to give you useful information to you. I think a crude example of this is, imagine you have a doctor who has read every medical book in the entire world. You go to this doctor with a specific condition, and they may not get it right because they know too much, versus if you go to a specialist with hematology, then they will treat your specific blood condition well. Does that track? And so there's a case to be made for smaller language models. Now, why am I saying this? Well, I run a podcast that developers tend to like, and this podcast is very, very long form. So if you look at the Apple page, there's like many episodes with some really great people, but look how long each episode is. I'm trying to pinch here. Look at this. An hour 42, an hour 48, an hour 33. Jeez Louise. People come to me and they're like, look, nice podcast, dude, but I don't have that kind of time. And so what I did to help them was build an AI-enabled search feature. And this is very cool because if you want information in a pinch, you just go get it. This is what it looks like. That's tage.as/podcast. And you could ask about anything. If you want to make your website faster, you may ask about resource hints. Anyone use resource hints? Yeah, no. It's a great way to make your website fast. So we could say something like, tell me about resource hints. And what it'll do is it will search every conversation we've ever had with every guest and give you the information that you're looking for right now. We discussed resource hints at this time with Dan Shapir, who's a web performance expert. And if you click on that shiny timestamp, you get taken to...
So I don't know how familiar you were with
He says the word, that point in time, and that's just AI generated. Now, I made this available to folks, and it was extremely, extremely expensive. Very expensive, because everyone started using it, and I almost went bankrupt. And so I decided, oh, we need to manage costs a little bit. And how do you do that? Small, specialized model, less compute. And also, the generated text output needs to have strong opinions, right? It needs to have this like markup that it generates with high precision to give you that shiny link. It needs to generate that markup, that code, that generative UI. So how do we reduce cost? You just create a small language model. This is the price projection between GPT-4o and the cheaper model, Mistral 7b, that I fine-tuned and custom-trained for my website. Look at that. I could be spending $15,000 for about 100K generation, slightly more, or this, which is very, very much less. This is the future.
He really persuaded me. Like, I'd never really thought about it that way. And as soon as I watched, like, as soon as I was listening to his talk, I was like, that makes perfect sense. The thing that it makes me think is it reminds me of sort of like the evolution of application development, where we went from these like monolith servers to these microservices that we compose together to build applications over time. It's like sort of as each part of software engineering becomes more mature, we get better at breaking it down into sort of highly specific fine-tuned parts and composing them together. And like you saw like the same sort of storyline, I don't know that it played out in like crypto too, where we went from like, oh, there's Bitcoin and Ethereum to there was like a plethora of people building like different base chains being like, it's really good for this one very specific thing, and then we're going to compose them together. And so I think what Tejas is saying not only makes sense, like as he says it, I'm like, technically that just like I believe this story, but I also think that's sort of the story arc of how like technology evolves in many examples, like over time. I think that's cool.
And since my model is specialized and fine-tuned to my data and my output, not only is it cheaper, it's more accurate. And that's why we need to do this now.
That's it. And now we're ready to move on to the next one. So the next talk last night was Zach from Warp, which we've also had on the podcast. Not Zach, but
we had a different Zach from Warp on the podcast.
Yeah.
We're just trying to get all of our, just the full coverage of that one specific thing.
So what do people actually use the terminal for? A lot of things is the short answer, right? We use it for version control. We use it to build, run, and test our software. Some people out there use it for coding. We also use it for database administration. Basically, we use it for a ton of things. And I think kind of that boils down to the fact that the terminal is the lowest level interface for using your computer, right? I don't know if people saw the Anthropic computer use API capability that came out a couple weeks ago. So that's like a feature of their API that allows Claude to effectively control your computer.
Everyone last night was such a good speaker. Like, everyone is so good.
So
like,
good.
I'm just watching this being like, this is like a TED Talk.
If you actually look at the reference implementation for the tools that they support, under the hood, they're issuing shell commands to simulate those mouse and keyboard interactions. So the point is basically that like anything that you can do on your computer, you can do from the terminal. We think about today, LLMs took a big step forward in sort of these like quote unquote agentic capabilities, right? We saw that kind of with GPT-4 and then 4o and then Claude 3.5 Sonnet. The thing I want to highlight here is that these models got pretty good at inferring user intent. And so we kind of had the thought at Warp, okay, if like now the models understand exactly what I'm trying to do based on my prompt, they're good at generating input, we've known this. They're good at interpreting output, we've known this. Why not just let them use the terminal? So enter agent mode, which is a feature that we launched earlier this year. And basically it lets you use or like leverage an LLM directly from the command line. And the idea here is like you can start to work at a higher level of abstraction than just shell commands, right? You can start to express your intent in terms of tasks in natural language and let the LLM do the busy work of translating that into the right sequence of commands to run. Let the LLM handle interpreting those commands' outputs and figure out what to do next. And basically leverage LLMs to make everyone a terminal power user, hence the name of the talk.
I think one of the interesting things that he didn't cover is today there is sort of a Warp agent feature where like you boot up the AI, you talk to the AI, and it helps you use your terminal. But it like as he's talking, it sort of seems like where his mind is at least, is like, no, that we like the terminal should be completely redesigned from the ground up. And this is like a great prototyping space for us to look at what the future might look like. But it like the idea that you have like an AI mode is like not what the next generation of like, great engineers are going to grow up with. So I'm like very bullish on Warp as a company. Like I think they just produce great product. I like fan of how they work, and like I'm sort of curious to see where their product evolves like 5 years out.
Yeah. But wait, are they talking about like literally just like instead of writing a command in code, you would just like in words say call a function for this or that?
Yeah, it would be like instead of you having to know the exact git commands to run in your terminal to push your code base to whatever, like merge it and do all the things, it's like, I want to open a PR.
That's awesome.
Save my work on Git, please. Merge this in.
That's so cool. I mean, the last talk that we have here is actually yours.
And this is the part that gets all awkward because I have to watch myself speak. I'll close my eyes.
And so building AI at Jam, we've learned a bunch of things, and I want to share them with you. So the first thing is the quality bar for AI is higher, I think, than for other features. Because all of you have had the experience of using bad AI, and doesn't it anger you? And that's because when you're building for developers, your audience is inherently not just skeptical, but they're actually trying to get something done. And when you clutter their utility with marketing fluff, doesn't it anger you? And so for us at Jam, we would rather not ship an AI feature we've already built than ship something that feels like marketing fluff. And so it means that we build features differently for AI than we build for other things. So our process is literally different. The first week of building an AI feature, we just build a proof of concept. It's like a hackathon week. And then together as a team, we make a go, no-go decision. Do we delete all our code, or do we merge it in? After that, we build a tool that's just internal to ourselves, and no user sees it until it's good enough for us. Then once it's good enough for us, we invite in 10.
So the backstory, of course, is it sounds like, it's like all planned, but what really happened is when we started like down the rabbit hole of like, could AI write more clearly and more concisely for engineers than a human could? And would that save that human time that they could spend like writing more tests, being more thoughtful about QA, testing the rest of the product, like doing literally anything else than like writing a ticket? Like, would that be really interesting? So when we started down this path, the engineers were very skeptical that we would get to something that didn't just feel like marketing. And the only way that they were willing to do, like to even explore, was if once we started exploring, there was a way that we could just delete and move on with like no harm done. And so we decided like, let's do like a hackathon week. And then at the end of the hackathon week, we'll make a go, no-go decision, and like no harm done if we've just wasted, a week or two of our like work lives. Like we can just move on easily. And I like love that they did that. So now it like feels like obvious in hindsight. Of course, for AI, like we don't want to ship something bad, but for every other feature we'd built before, you just start building it and then you get it good and then you ship it. And I like love that they introduced like, no, for AI specifically, it actually has to be like we'd rather delete than ship something that we feel like is mid.
But it really, really matters that the quality bar is really high.
One of the things that I really like working with our team is that there's sort of like, it's not quite true, but there's sort of like a reputation for like, oh, the product manager really cares about hearing from users, like the designer does, but the engineers are like more interested in like the technology or something. That's like not true in our team. And actually the people who are pushing the most for like, what did users say this week? How are users using it this week? Are the engineers on this project, because they're so focused on making sure that when this ships, it's actually good for users, because they like don't want to waste their time building something that users feel like is just like cheap AI. So anyway, I like love that.
So here's another interesting decision that we had building this AI feature I showed you. Should it be opt-in, press a button to generate a ticket for me, or is it automatic? We just write the AI description for you every single time. We had a decision to make. How many of you would have chosen button to write the ticket? How many would have chosen just write it for the user no matter what? What we decided is either the feature is good or it's not. And if it's good, it should write every ticket. And if it's not good, then like what? Are we going to let the user choose whether to see a bad ticket? Like either we believe in it or we don't. And so we decided it has to be automatic, it has to be there every time, and that's only if we're proud of the feature, and otherwise it just shouldn't ship. So there's no in-between for AI.
Or allow the user to just like delete the auto-generated content very easily.
Yes, so that's actually what we went with. So it's tab complete.
Okay, if I'm being honest, this is one of the decisions that like keeps me up at night, right? Like where we're like, hey, we believe that this AI is so good that we're gonna make it part of the jam experience for every single jam you create. And because we are proud of this feature and we're not hiding it. Like there's no AI behind a button just to have AI. It's like we think that this should be the core new way that you report bugs. That's like such a scary and bold decision to make. And so if I am being honest, like as I'm watching this, I'm like, this sounds right to me. I still believe it. But like when we look back in 6 months, one of the mistakes we might have made is having to like put the AI a little bit like to be like, oh wait, this shouldn't be in every jam or something. Like there's something about this that is like it's like a very vulnerable and scary product decision to make of all the product decisions, that we make. But we've iterated a bit on it, which is interesting. So it used to be that like basically it would just write the ticket for you and then highlight the text. So you could just write over it if you wanted to, or like put your cursor right in the middle to like edit one thing. But that actually felt like maybe a little bit too aggressive, because if you wanted to have no description, like if you felt like the graphics of the bug report speak for themselves, then you'd have to actively go back and delete. And so we changed it to, it's like the AI writes basically like placeholder text that's tabbed to complete. And so that feels like a lot nicer. And so it's actually kind of cool how Chris, the designer on this, found this like nice in between where it's both opt-in and automatic. So you always see it. It is always part of the core experience because we believe it is faster and better, but it still has an opt-in mode. So it's not hidden behind anything, but there is still an action you take to accept it. Anyway, like that.
You know what, that approach reminds me a lot of like how Superhuman approaches AI a lot of the time.
Yes, smart reply.
Because it's like, it's not anything you're supposed to turn on, but it's nothing that you must use.
Yes.
But it's always there and it's useful.
Yeah, that's the mental model here. Like I don't use Superhuman, I use Gmail, but Gmail has like they'll just show you what you could be writing, and then you just tab to like keep taking their suggestions. And so that's where this comes from.
Right now we have an early access program, and 1 out of every 5 tickets gets tabbed complete exactly as the AI wrote it, which is pretty cool. Imagine being in QA or being a PM and not having to write 1 out of every 5 tickets. So everyone knows in AI, it's like garbage in, garbage out. It's like the quality of your inputs equals the quality of your outputs. Usually that we're talking about data quality, but here we also want qualitative feedback and quantitative feedback. So we've set up a lot of systems that we review every single Monday as an AI team to make sure that what we're building is high quality. So that's what's the acceptance rate of our AI suggestions. It's what's the thumbs up versus thumbs down rate by users. And we are constantly emailing those 59 early access users, both to give them like in-email surveys, like 2 questions in line, or to ask to hop on a call, and then we share the like clips from the call in the AI team to discuss. Okay, when you're designing AI, doesn't it just, it's just like, wow, magic feature. And so all the designers are like, let's make it look like magic, right? Like every AI feature you've seen on the internet kind of looks magical, right? Lots of pinks and purples. But actually, that's not what we believe about AI. We believe that AI is just a utility to get things done. And if that's the case, then we should make it just blend into the product. And so one design decision we've made is just to make it boring, grayscale, and not magical. The last thing I want to share is what tools we're using that we found really helpful to improve our prompt. So the first one is the engineers on the team love prompt foo. How many of you are using that? It's like Google Sheets plus evals for engineers. It's really, really awesome. The other is, how many of you have heard of glyph.xyz? We shared a designer with Glyph. The same AI designer at Jam also designed Glyph. So we're a little biased, but it's sort of a no-code builder for AI tools. And what it allows our designer to do is he can create a prototype of our product using Glyph, work on the prompt himself, and then share it back with engineers. But really, the best tools for us have just been the boring ones. Just having a Notion that's an experiment log of everything we've tried in AI, and a meta-based dashboard to track our quality has honestly been game-changing. So these are the 5 lessons building at AI Jam, and thank you.
It was a really fun event. Ivana, thank you for, you did all the hard work behind the scenes. Thank you.
Thanks, but you guys did it all. You were there, and you got to see everyone. That's awesome.
It was really, really nice.
But we're hosting another one in January. If you're in San Francisco, come. It's at GitHub on the 8th. Bye, everyone.